And welcome everybody to the Daily Space Weather Show. No time to screw around today. There's a geomagnetic storm in progress. That's the past 24 hours, the closest star there, ionized helium from SDO. And just so you know, we just recently released a new video. If you haven't checked it out, check out the Ask a Particle Physicist playlist. The 21st video, Barycenter versus Sunspot Cycles, has appeared on the playlist. Also, make sure you're subscribed to Eugene the Philosopher, the creator of those. And there's a little teaser. It shows the location of the sun, the location of the Barycenter, number of sunspots, as well as the year. So, just so you're aware of that. Ask a Particle Physicist playlist at youtube.com/smashomash/playlists. These are 24-hour videos at 30 frames per second from Solar Dynamics Observatory. Massive plasma filament there, just moving into the western longitudes of the southern hemisphere. We named it yesterday on the video the Charles Barkley filament. It's been looking increasingly unstable for the past 24 hours. Hoping that one ejects soon. Again, we do have a geomagnetic storm condition. Got all the way to a G3, although it's going to subside rapidly. Sorry, Aurora Chasers. It's going to subside quite quickly indeed. So here's a 48-hour video. That's 131 angstroms, and things have been pretty quiet on the closest star for the past 24 hours, so not super exciting, although we do see some flaring activity kicking up down here in this southeastern quadrant, right down there. A little bit of flare activity happening on a new sunspot. So not a lot to be frightened of today, but we'll find stuff. We'll find stuff to make you frightened. By the way, if you enjoy the content, press the like button, press subscribe, tell your friends and foes about the channel. And yeah, we're delighted to bring you the world's most comprehensive daily space weather content and most detailed solar imagery here at the Smash News Network. Least busted name in news. One of the ways you can support the channel is by picking up some merch. You can find links below the video to the merch, our Amazon shop, and so forth. And there'll be more merch coming out soon here as we've just rebranded in the past couple of months. And thanks to everybody who has supported the channel, increasing the probability that these videos will continue to exist, remain publicly visible, and free for all to view. Cheers. Moving to volcanoes real quick. Shivaluch has created a new lava dome, so a new eruption perhaps fixing to occur there on the Kamchatka Peninsula. Shivaluch grew a new lava dome. Mount Ibu there is exploding. Dukono, Ruang has calmed way down. It's only producing an 8,000-foot ash plume now, so big downtick at Ruang. Tofua, unknown volcanic ash cloud there. Popocatépetl, 19,000-foot ash plume. Santiaguido, Fuego, Nevado de Ruiz, Sangay, all exploding. Also, Revenador producing a 15,000-foot plume of volcanic ash. Please do not pole vault the caldera. Again, please do visit the links below the video. There are the past 90 days. And check it out. We've got a large earthquake in California, or at least noteworthy, a 4.1. We usually only call out 5 magnitude quakes, but dudes, keep in mind any earthquake can be a foreshock. 4.1 there in Southern California at Corona. So these are the 5 and greater magnitude quakes. Vanuatu had a 5.0. It was at extreme depth, about 230 kilometers. Papua New Guinea saw the largest quake of the past 24, I think, at a 5.9. That was late last night at 23:45. Keep in mind, folks, this video is coming out a little bit earlier today, and I won't be able to view the live premiere. Details on that later. They're currently classified. Peru also had a 5.1 magnitude quake. South Sandwich Islands had a 5.0 and a 5.4, making that 5.0 a foreshock. Alaska had a 5.5, so that one kind of just came out of nowhere. And yeah, 5.5 at Alaska, and then a 5.1, and several other aftershocks like that 5.3 and that 5.4. Out deep in the Aleutian Islands, also South Sandwich Islands had a 5.2, an aftershock there. Again, keep in mind, folks, any earthquake can be a foreshock, and let's get back to space weather stats. The 10.7 centimeter radial flux is now at 132? 135 solar flux units. And if you're wondering what a solar flux unit is, it's 10,000 Jansky of radio flux. Now, who doesn't measure their radio flux in Jansky? People that aren't astronomers, that's who. So, anyway, that's the past year. The black line represents the radio flux The red line represents a sunspot number. And yeah, we just reached a new high in sunspot number, about 284 sunspots. Space Weather Enthusiast dashboard here didn't forecast any kind of geomagnetic storms. Now, we told you multiple CMEs were in the process of rolling in, and I think we just have received the last one. So after this, there's only a coronal hole high-speed stream on the way. But KP7, we reached all the way to a G3 class geomagnetic storm. Really, it was 6.67, but pretty close there to a KP7. It counts. They get rounded up. So geomagnetic unrest forecasted there for Saturday night into Sunday morning by NOAA. That is the coronal hole high-speed stream. There's NOAA's Enlil spiral. We'll briefly put that up. We'll also show ESA's Enlil spiral, which is a little bit different, but it is showing ultimately the same thing. Coronal hole high-speed stream to show up a little bit later there on ESA, which I actually think is going to be more accurate. Showing up there, density spike on the 5th into the 6th. Earth magnetic moment from space looking like this, and you're going to see the pressure drop down a little bit here because over the past few hours, the vertical component of the magnetic field in the solar wind changed to such an orientation that's not very good for the induction of currents in the earthly system. So there it is, Earth magnetic moment from space for the past 4 hours. Here's Earth magnetic moment from the ground for the past 4 hours. Yeah, it looks like the geomagnetic storm is going to rapidly subside here. So we'll tell you why momentarily. And if you are hunting the aurora, the ground magnetic perturbations map might help you. We may have some ability to see the aurora tonight around the equator, but probably not, again, because things are subsiding. We did see a significant spike in the U.S. power grid. And make sure you follow us on Twitter, x.com/SmashOmash. There you can see some significant induction into the geoelectric fields as measured by the power lines themselves. Next KP index is going to come back down quickly. So it did reach 6.67. The next update, it's not going to be at 6.67 next time. And here's why. The magnetic field has rapidly shifted. So we had a strong negative BZ signal there for a few hours, about 2.5 hours, and that now switched to a positive BZ. So we'll come right back out of geomagnetic storm conditions. The field itself is still pretty strong and could shift more. So fingers crossed for that. That's the data from the ACE. Let's call out the data for the Discovery. Current conditions are about 15.5 protons per cubic centimeter for the solar wind density. Solar wind velocity here about 440 kilometers per second. Although you can see the fields there consistently did shift similarly. Total field there is 19 nanotesla with a BZ of positive 4. There are our GOES magnetometers, and you can see they experience some major magnetic fluctuations out there. Now keep in mind that is only nanotesla, so those are very weak fields, folks. That is the Earth's magnetic field. The outer portion of the outer Van Allen belt is where the geosynchronous orbits of the GOES 16 and GOES 18 are occurring. Next, magnetic sectors, and Earth is in a North Pole sector. Nothing to write home about there. Could change rapidly. We do see some volatility happening in the eastern side of the solar disk. Mainly that sunspot in the southeast. So here you should see the B field moving around a little bit there on the east side, which would be your screen left, and indeed you do. That's because we're not exactly sure the magnetic sector that's coming, as sunspots can help obscure it. Anyway, here's our line of sight coronal hole plot, and we've got indeed some south pole oriented coronal holes here rotating in, but they're looking kind of weak in terms of their polarity. And let's move to the SDO. There you go. And you may be wondering if coronal holes can be used to forecast earthquakes. And the answer is, well, absolutely not. They can't be used to forecast earthquakes any more than sheep's bladders can be employed to prevent earthquakes. Not a thing. So no matter how confident the charlatan sounds when he's saying these untrue, ridiculous things about coronal holes being able to forecast earthquakes, it doesn't make any difference, because reality doesn't change, because charlatans sound confidently. Don't fall for utter bamboozlery and believe that somehow people are forecasting earthquakes via coronal holes. It's not a thing. And frankly, it's very stupid. Sunspot number here has now recently come up back above the monthly average. So the current average is about 120 sunspots, and now the number of sunspots has risen over 130. So sunspot number average being pulled up once again, and you can expect that to continue until something like October of 2024, when we expect to reach solar sunspot maximum, a reasonable forecast that sane people would find themselves believing. So next is our flare probability monitor and scoreboard, and frankly, this is incorrect. I mean, it's showing the most likely place for a large flare is up there in the northeast from sunspot 3663, but in reality 3664 in the southeast is the one that's been the most active for now. So just realize that the one in the northeast is able to, well, it does have the kind of magnetic fields where it could produce a large flare, but at the moment, realistically speaking, 3664 down there in the lower left has been more active. We'll show you both in close-up detail. There's another 30 frames per second, 24-hour video. And I told you we'd find things to make you frightened of. So don't worry, we won't hesitate. Of course, everybody knows that in nature, shapes are very scary. And this series of sunspots is forming into roughly a triangle shape. And so, I mean, look, triangle shapes, dude, very spooked of triangle shapes. You should be very spooked of triangle shapes as well. Make sure that you purchase an underground missile silo or some other sort of bunker. Perhaps bulldoze a few planes on top of each other and bury them in the ground. Maybe you could bunker in an old jet fuselage. That sounds like a great idea, because there's nothing spookier than a series of umbrae roughly in the shape of a triangle. Pardon my sarcasm, but people will believe anything. Even if you put the correct information right in front of their face, some of them will continue to believe utter nonsense. So here are 3 sunspot groups in the Northern Hemisphere. Actually, I think it's 4. But yeah, so that's what's going on for sunspots, and it's been pretty chill indeed. Next, we've got to move to things like the Proton Flux. So no spikes, just some minor little upticks there in the Proton Flux. And the probability of sunspot 3654 now producing a large flare are dropping. So for the next about 24 hours, we'll still have some possibility of it producing an MRX class event. But over the past 24 hours, we've only had 2 M-class events, mostly just C-class intensifications. And let's move to the SDO. There we are. There's 94 angstroms. So yeah, the T-mass is now that sunspot down there in the southeast. As sunspot 3654 sets in the southwest, which would be your screen lower right. Yeah, right there. Alrighty, so let's next go to solar system forecasts. So this is what's currently going on in the solar system. Here's your 1-week forecast as we approach new moon. That's where things will be in 7 days on May 9th. Here is what's going on overhead right now, Lehigh Valley, Pennsylvania. And if you've got a low horizon, you may see Jupiter just after sunset. Sometimes the 3rd most bright object in the sky, sometimes the 4th brightest object, and sometimes the 5th brightest object, depending on the proximity of Mars and Jupiter. Astronomy photo of the day is M100, the 100th entry in the Messier catalog, also known as NGC 4321, the 4,321st entry into the new general catalog. It's a spiral galaxy, and you can read all about it if you like at apod.nasa.gov. Next, CMEs, and they've been pretty chill as well. They are not earthly directed. We'll briefly show those in a little greater detail here. We'll also show Stereo A now that we've showed LASCO C2 and C3. And if you're wondering what that is, Stereo A's got a planet. That would be... I don't know. I don't know what that is. Let us know in the comments if you look it up on Stereo A's website. Could it be Jupiter? I don't think it's Jupiter, but anyway. Yeah, some object there. And of course, let us know in the comments if you're mad because you think we're hiding a spaceship. Just a planet-sized spaceship out there. So yeah, some CME action there. Gotta love it. And let's move on to our custom coronagraphs. Yowzers! We've also got a comet originating from toward our Earth scale there. Right at the beginning of the video. There it goes, and it's evaporated. Vaporized. Bye-bye. There's a little closer view. Again, the Chas-Barkley filament. Right in the south-central part of the solar disk there, just moving into western longitudes. Some huge prominences there setting in the west. Here's a close-up of the Chas-Barkley filament. And it's time to get the bonus features and blast through meteorology. But first, filaments. Yeah, filaments. That's the right thing. There we go. Yeah, so check out the Chas-Barkley filament. Like I said, it's getting a little bit more unstable here for the past 24 hours. So fingers crossed, we want to see that one eject. Preferably when it's in the Earth-facing zone. Because space weather arriving at Earth, not scary. Active star, not scary. Inactive star, not scary. All right, by the way, make sure you follow us on Twitter. If you don't, you may not see brilliant conversations like this. Keith Strong citing how many solar flares have happened versus solar cycle 24. And then, of course, cultists will chime in and say, look, it's the weakest solar cycle in hundreds of years, in over a century, which is completely untrue. Because here's the graph that we just showed today. So, yeah, make sure you follow us over there. Follow the hashtag #NameThatFilament. Name that filament. To name filaments after your friends, your foes, or perhaps even yourself. Again, the most active sunspot has just recently become that one in the southeast. As you can see, there's some material possibly blasting off. Looks like a minor CME would have been generated from that. And also a little bit of an uptick in the solar flare profile. Bonus features are next. Satellite charging hazards are minor. They're of the surface variety when electrons are building up on the outside of spacecraft. They're Southeast Asia, some minor surface charging hazards. The ghost electron flux here is cratered, as you'd expect, during a G3 geomagnetic storm. The next update will show that way down, and there it is, way down on the electron flux. And there's NOAA's forecast model, not too shabby. Not too shabby, NOAA. We'll show the layer where it's measured and its vibrational frequency, the diffuse gas between space and Earth. The F layer is at about 300 kilometers of altitude. There it is. And we will see a bunch of low-frequency anomalies, indeed very low-frequency anomalies. A sudden impulse has struck the Earth. And there is plasma. Plasma, I tell you. So there you'll see a lot of red lighting up on the anomalygram. That's anomaly in megahertz from a 30-day median. Lots of red, low-frequency anomalies. As the ionosphere gets both lower and higher, it expands both upward and downward during times of geomagnetic storms. And you've got all of the indications of a significant geomagnetic storm there on our animation. So lots of current got induced, lots of material came hurtling in. So here's our global ionosphere nowcast. Total electron content over here on the left. Maximum usable HF radio frequency over there on the right. Anomaly grams on the bottom. So major GPS errors continuing in the Pacific Ocean, especially. mainly the Pacific Ocean. We'll close out space weather with the latest intensitygram and magnetogram. Yeah, this is the most likely place for a large solar flare at this point. That is major magnetic shear there. So that ain't no joke. That is a legit magnetically complex beta gamma class sunspot. Is it beta gamma delta? Yes, it is beta gamma delta. And there's the full disk view. And let's get to meteorology. Surface winds of the eastern world are first. Shout out to our viewers from all around the planet. Who knew that we'd make so many friends by putting out factual information about space weather? Seems so easy, yet very rare is the channel that does it. Jet streams of the east here. Jet streams of the central world. Surface winds of the central world. Surface winds of the west. And the jet streams, evidenced by the 250 hectopascal winds. Satellite imagery is next. Clear skies over most of Brazil until night falls, and then the clouds start forming. How about them apples? Visible satellite for the Americas. Pretty sweet. Next, our windy.com map, and the western half of the country, really most of the country here, only the central country, basically the Mississippi Valley, is characterized by moisture. The rest of the country there, save for Oregon, is pretty dry indeed. That's mean sea level pressure. Here's our weather.gov map, weather.gov. A lot of counties lit there, especially in Texas. If your location is lit in Texas, don't just go grab a soda pop here on a Thursday. Go get your weather reports, your weather warnings from weather.gov, the National Weather Service homepage. Temperature anomaly forecast is first. That's in degrees Celsius. We've got a mixed bag of anomalously warm and anomalously cool temperatures across the country. Total accumulated precip is going to feature some very, very heavy rains that are really already underway in Texas and Louisiana especially. But there's the map. Read 'em and weep. Snow continues to fall into May, with the heaviest snow there in California. A system is just going to slide right down the California-Nevada border. And no, it wasn't man-made. Humans are unable to put all that moisture into the atmosphere, folks. Last but not least, pressure and precipitation, GFS 72-hour model, like the other forecast we showed you. Heavy Pacific moisture there making its way in once again to the Pacific Northwest. Those are brought to you by tropicaltidbits.com, by the way. Maybe go follow Levi Cohen on Twitter. He's got his fingers crossed for hurricanes. He does not like Saharan dust. There's lightning. How about a real-time lightning map? We do have a few cells here. Center City, Houston's got thunder rolling in. Check it out. Dear God. We're going to close out the video with U.S. Doppler radar. We'll briefly show the full 50-state view. And then we'll fixate on the lower 48 view. There's your satellite imagery. And there is your water vapor map. Impress your friends by understanding how to use the water vapor map to forecast your weather. Those differences in the moisture in the atmosphere also represent pressure gradients in most cases. And those are able to explain things like rapid atmospheric changes. Unlike things like HARP and cloud seeding and other nonsense that has nothing to do with weather. Here's your recap. Doppler radar. visible satellite. No chemtrails are visible on the map. And there is the water vapor map. Hopefully that clears things up. And whether it has or not, visit the links below the video. Don't forget to check out the latest Ask a Particle Physicist segment. And we'll be back next time with some more space weather. But in the meantime, may that solar wind be at your back.